Hello everybody, getting ready to do lesson 5.4, completing the square of SAT Math Level 1 prep. Contact me here for course materials and tutoring, etc. 5.4, completing the square. We have 48 points here on your tune-up sheet and 40 points here of note-taking during this lesson. Get ready for that. Overview of this section here. This section explains how to complete the square and shows how it can be used to solve quadratic equations, including those that cannot be solved by factoring. So that which cannot be solved by factoring is a huge matter here, so we can complete the square and solve them. So how to complete the square? Sometimes it is useful to complete the square within a quadratic expression so that it includes the square of a binomial. So to complete the square of a quadratic trinomial of the form x squared plus bx plus c, add and then subtract b over 2 squared. So this member here, you divide it by 2 and then square it and then you add it, and then that will complete. So let's see how we can do that. To complete the square of x squared plus 10x plus 7, add and then subtract 10 over 2, this is your b here, 10 over 2, and then square it, equals 25. So what would that look like in the expression? X squared plus 10x plus 7 would equal x squared plus 10x plus 25, because 10 over 2 is 5 squared, plus 7, we don't forget this, plus 7, and then we subtract 25 as well. So perfect square, this is a perfect square here, x plus 5, this is x plus 5 squared, minus 18. Now we combine these two terms over here and we get negative 18. So this is our completing the square solution for this trinomial here. To complete the square within a quadratic expression having the form ax squared plus bx plus c, first factor out a from the variable terms. So we have to factor that out first. So like in this situation here, 2x squared minus 12x plus 5, we can factor out a 2 here. We have to make our a term 1. So this works here, but what about 2? What about 5 over 2 plus 5 here? What do we get that? So we take 1/2 of b and then square it, and it's 9 plus 5 minus 18 here. This is 18 here because 2 times 9 is 18, and we subtract it. We're adding it here, and then outside the parentheses we're subtracting it here. 2 times 9 is and then we subtract a negative 18. So this becomes 2 times the quantity x minus 3 squared. This is a perfect square here, minus 13. So this can be tricky here because it is, inside of parentheses here. This is how you handle that, because you factored out a 2, and you don't forget that when you add your term out here of negative 18. Since 2 times 9 is being added to complete the square, 18 also needs to be subtracted in order to produce an equivalent expression. So we're adding it and then we're subtracting it. And then when we do that, we get this here, negative 13, outside of this situation here. Okay, so solving non-factorable quadratic equations. Any quadratic equation, including those that are not factorable, can be solved by putting them in the form of x plus p squared equals k, and then taking the square root of both sides of the equation. So in this situation here, x squared minus ax plus 9 equals 0. By the square, rewrite the equation as x squared minus ax equals negative 9. So move our constant over here. So only in terms involving x are on one side of the equation over here. Complete the square by adding negative 8 over 2 squared. So this is our b here. So we add that 16 to both sides of the equation. So now we have x squared minus ax plus 16 equals negative 9 plus 16. So that becomes x squared minus ax plus 16 equals 7. Now we have our situation here. X minus 4, this is perfect square here. X minus 4 squared equals 7. Take the square root of both sides of the equation. So when we do that, we have x minus 4 equals plus the square root of 7 or minus the square root of 7. And then we solve for x. So x equals 4 plus square root of 7 or x equals 4 minus square root of 7. So that would be another way that you could solve these non-factorable quadratics. Solving a quadratic equation by completing the square. So to solve a quadratic equation by completing the square, rewrite the quadratic in the form x squared plus bx equals k. Add the number that completes the square to both sides of the equation. Take the square root of both sides of the equation and solve for x. So that is another way of doing it when they're a little bit more complicated. Now, the quadratic formula, if you need to find a solution to a quadratic equation, you may find it easier to use a quadratic formula. Quadratic formula is ax squared plus bx plus c equals 0. Then x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Here is your quadratic formula. This is important. Since a quadratic formula is not included in the SAT formula reference sheet, you should memorize this. You need to memorize this. Okay, so we got a situation. What are the solutions of y squared plus 6y plus 7 equals 0? So we need to find that. Since quadratic trinomial is not factorable, there's no way we can get our b from our factors of our constant here. So by either completing the square or using a quadratic formula. So let us rewrite the equation as this way here. We have a negative. Solve it by completing the square. So maybe this will work. So let's try that by completing the square with moving over our constant to the other side. 6 over 2 squared is 9. So, okay. So xy squared plus 6y plus 9 equals negative 7 plus 9. So this equals this over here. Take the square root of both sides. So we have y plus 3 equals plus or minus square root of 2. That would be one way you could do it. Solve for y. So when we have this situation, we have two possible solutions here. Solve using the quadratic formula. This would be another way method too. This is one set of solutions up here. Now we're going to use quadratic formula to check it actually. So we can plug in our values here into our quadratic formula from our original trinomial. So when you plug in our values here from our original trinomial, we get this set up here. What does that give us? So we have negative 6 plus or minus a square root of 36 minus 28 over 2. And we get negative 6 plus or minus square root of 8 over 2, which is, we factor out, we're going to do this by hand here. Negative 3 plus or minus square root of 2. That would be your two solutions there. That would be your x-intercepts right here. So solve for x squared minus 8x minus 3 by completing the square. Transpose the constant term, negative 3, to the right side of the equation, and factor out 4 from the left side. So when we do that, we have this situation here. 4 times x squared minus 2x equals 3. Complete the square by adding negative 2 over 2 squared equals 1 inside parentheses. So since this is being multiplied by 4, you must add 4 times 1 here. So this is your b here. So 4 times 1, you got to add that to both sides. So when you do that, you get this situation here where you have 1 here, and then 4 times 1 equals 4. You add that over here. So x minus 1 is perfect square here. X minus 1 squared equals 7 over 4. Because we divide 4 out from both sides. Solve for x by taking the square root of both sides of the equation. So when we do that, we have x minus 1 equals the square root of 7 over 2. Because when you take the square root of this thing here, you still have the square root of 7, but the square root of 4 is 2, which can be further elaborated as x minus 1 equals the negative square root of 7 over 2, or x equals 1 plus the square root of 7 over 2. Those are your two solutions, or x equals 1 minus the square root of 7 over 2. What is the smallest integral value of x for which the roots of 3x squared plus ax minus k equals 0 are real? So to keep it real, the roots of a quadratic equation are real when the discriminant is greater than or equal to 0. If 3x squared plus ax minus k equals 0, then a equals 3, b equals 8, and c equals a negative k. So b squared minus 4ac has got to be greater than or equal to 0 in this situation. So when we plug in our values here, we have our b, we have our 4 times our a, which is 3, and then c is the negative k. It's got to be greater than 0. So we're going to solve for k within that situation. 64 plus 12k is greater than or equal to 0. Then 12k is greater than or equal to negative 64. So when we divide through by 12, k has got to be greater than or equal to negative 64 over 12, which is negative 5 1/3. So the smallest integral value of k that satisfies the inequality is negative 5. So that would be how you would solve that problem. Sum and product of roots. A quick way of finding the sum or product of the solutions to a quadratic equation without actually solving an equation is to use the formula, sum and product of roots formula. So if ax squared plus bx plus c equals 0, then the sum of the two roots, negative b over a, and the product of the two roots, c over a, by what amount does the product of solutions of 3x squared minus 10x plus 13 equals 0 exceed the sum of its solutions? So sum of the solutions, negative b over a, would equal the negative of negative 10, this is your b, over a equals 10 over 3. So the product of the solutions, c over a, which is 13 over 3, product of the solution that exceeds their sum by 13 over 3 minus 10 over 3 equals 1. So that would be how you would solve that. And that is 5.4 of your lesson. Thank you very much.